Hey everyone, welcome to Module 6. I just want to talk about this briefly and talk a little bit about the lab. Module 6 is something called spatial interpolation. And interpolation, what is often created is a raster surface. So that's why we're talking about it here at the very end of the course, since we've been getting into different rasters. And so it's interesting because what you actually do is you put in a number of sample points into the interpolation. So you're actually putting in a vector, a shapefile of points that you've sampled across a location. And then what you're doing is creating then this raster surface that will give you values for all the places that you didn't actually get a chance to sample. And one of the easiest kind of things to think about as far as spatial interpolation is think about, say, a temperature map. And you have all these different locations, say weather stations, where they select and take the temperatures at any given time. Well, you can't do that for every location. So what do? You interpolate a surface, and that's oftentimes what you see, like in the evening news, whenever they're doing the weather. If you guys watch the evening news, you're too young. You don't watch the news. But like if you see like a typical kind of weather map that shows the temperature across an area, that's a kind of interpolation. And that's what we're doing. So we need to talk about different methods and methodologies here. And so like there's something called deterministic methods, which is all about how you do a specific kind of prediction. And then you get into some of this here with the inverse distance weighting as a technique, the natural neighbor, a trend surface. And then we get into something called geostatistical methods. And this is the most spatially aware, spatially, I'll say, correct way of doing things. And that's through a technique called kriging. And what's really great about kriging is it not only takes then into consideration the error, the variance that sampling might have, but then also it takes into consideration a spatial trend that the data might actually have inherent to itself. As you know, temperature will automatically increase as you go south. That's just a natural flow as a change in latitude, or decrease as you go north in latitude, just as a natural trend. And so kriging will actually take things like that into consideration while constructing a surface. And so we want to look at the lab of this. You have obviously these two quizzes that deal with deterministic interpolation and geostatistical interpolation. But like what we're mainly concerned about here is the lab. And the lab here, like I said, we'll walk you through some of the interpolation. You're going to get then an XY, you're going to get your points from a data table, and you'll eventually go into interpolation. This is IDW, inverse distance weighting, a deterministic method, surface trending, and then by kriging. And then kriging is, like I said, one of the most common ways in which an interpolation surface is created. It often is thought of as one of the most accurate because it takes error into consideration. And there's a lot of steps that go through this. And what you're going to be doing is you're going to be creating 3 different surfaces with these different methods through the kriging, the trend surface, and the IDW, just to see how they're different, how they create the different surfaces using the same data. So it's a pretty straightforward lab. There's not a lot of complexity to it. You want to make sure you're setting up your map so that you're displaying your data appropriately and having like the 3 different maps, lined up as far as the size of the data frame and the scale and all that. And then you have questions here to answer. Okay. Like I said, it's relatively short, very straightforward. Don't forget to get the final done also at some point in time, and then I am working on your flow charts, and I'll get those back to you within a day or so that you'll have those to work on, okay? If you have questions about your project, please feel free to contact me. If I can't answer the question within emails, we can always set up a time to talk about it and help you through anything you're working through, okay? So I'm going to look forward to seeing, there's some great project ideas. I'm looking forward to seeing them. It's been great working with you. We are very close to the end, as I said. So I hope you're going to have a great rest of your week, and I will talk to you soon.